Hello and welcome to this first video of Ansa. My name is Benedetto Ximeno Frank and I'm going to show you how to use the program, at least the most basic stuff. Also, it's going to be quite similar on the lessons that we are doing on advanced aerodynamics. And basically these videos are just for you to review a little bit the content that we did in class in a more direct way and without any interruption. So basically, if you remember, when you open Ansa, you have to choose between the layout that you want to use depending on the application. All the layouts are going to have the same functions, but the difference is how close to the functions we are. No? So basically, we're going to pick the CFD layout because we're going to have all the CFD functions visible for us at all time. So we press OK, and now Ansa opens. So this is the main window from Ansa, where if we have been working with other geometries and other cases, we're going to have here all our previous works. Right now, basically, we want to create a new file. So when we have this new file, basically here we just see the coordinates origin and nothing else. No. Basically, well, this first video is going to cover a little bit the introduction about Ansa. So basically, I'm going to talk you about the main functions of Ansa and how the program is structured so that you are able to understand and to find quicker the functions and why are we going to use the functions afterwards. Of course, we're going to see examples of how to use all these functions while we work with it, and it's when you're going to understand the differences between functions and why they are used. But I want to make this brief introduction first. So basically, well, we have several groups of buttons here in Ansa. If we start here in the top left, basically we start with, let's say, some of the general commands for all codes, all this file, well, with creating a new file, opening a new one, merging one mesh or another model to the model that we have, or in these buttons is where we can just make input from other codes or do an output to CAD, and all these things. Also, one of the important things from here is that if we work with version 22, for example, then we cannot open version 22 files in version 21 or version 20 unless we save it as version 21. Okay, if not, we're not going to be able to open it. That's important to keep in mind, that you need to work always with the same version for more efficiency and to avoid any kind of problems. Then we have one important menu, that it's a properties or PID menu. Basically, we can also access it pressing Ctrl P. Here we're going to have all the PIDs. PIDs are basically a group of faces and entities that we are going to create. For example, if we are meshing a car, we can create a PID for the mirrors, for the front bonnet, for the for the wheels, and several parts of the car. Or we can also create a whole PID for the whole car. That depends on what we want to see and a little bit on our level of classification that we need. But what's important from PIDs is that afterwards, to set different boundary conditions, we are going to have different PIDs. So basically, what's clear is that we're going to need a PID for the inlet, PID for walls, a PID for symmetries, PID for the outlet. So that are going to be our minimum PIDs, but then we can also have more PIDs with the same boundary condition. And for example, we can use these different PIDs to play with the visibility of them. So we can hide the whole PID group, for example, or thanks to having different PIDs, when we post-process the results, we can compute the drag generated or the lift only by one of these components that we have in one PID. But what's important to understand is that PIDs are the group of entities that we're going to use the most. Then in Ansa we also have the parts or the sets, but PIDs is the one that we're going to be working with. We can, at the moment, forget about the other ones and keep this menu in mind and this name in mind, because we're going to come a lot to it, no? So afterwards, we have some, well, we can say additional tools that most of them we are not going to use it. For example, we have scripting, so we can automatize all our processes with Python scripts that work with an Ansa Python library. But we also have, for example, here batch mesh. That's a tool that we are going to use for meshing when we get into the driver or for when you do the aircraft project. And also from here, it's important to know that we have all the checks and all the possibility to check all the geometry and everything. So if you don't have experience in meshing, let me explain you that when you mesh, for example, when you import the geometry, if you have any issue in the geometry, most possibly you're not going to be able to create the surface mesh. And even if you are able to create it, this issue is going only to get worse with the steps that you do. It's never going to improve. So basically it's important that, for example, when you have the geometry, you check this geometry. When you have the surface mesh, you check it, and so on and so forth, to ensure that you're not going to have any problem when you have the final volume mesh, no? So basically here you have all these checks. We are going to see them while we work. This is just a brief introduction. And finally, the other button that is important is the settings button. That's quite crucial. So let's enter these setting menus. We have lots of settings here, no? We have quite a lot of stuff which we are not going to cover. Here, for example, we have this translators part, that is when we import a cat, how do we want to make the import depending on the format that it is. Not our business right now, but what's important for us is the resolution, tolerances, units part. Units, it's in millimeters by default. That's a problem, okay? We are not going to touch it right now because we don't want to work in meters. Ansa has some more precision when we work with millimeters, but we must make sure that we scale the mesh before exporting it, because if not, we're going to have the lengths wrong, and if we have the lengths wrong, our Reynolds numbers in the simulations are going to be not wrong, and the simulations are going to diverge. So we need to remember that this is extremely important. Then about the resolution and tolerances. Basically the resolution, it's just the resolution that we're going to have when plotting curves or cons that are what we name curves on surfaces in Ansa. I'm going to show you some examples afterwards. These are the resolutions when the curves are presented on screen. So basically, if we decrease this resolution, we are going to see a more accurate curve. Let's imagine a circle. If our resolution is 2 cores, we're going to see more a polygon, even a square, than a circle itself. If we decrease this resolution value, we're going to have more sides, and we're going to have something closer to a circle. But still, for Ansa, it's still a circle, so it's just a matter of visualization. Obviously, the lower the resolution, the higher the time that it takes for Ansa to render geometries. So when we work with really complex models, really hard geometries, it's better to keep a high resolution. If we work with something simpler, we can decrease it. But that's something just to keep in mind, that you don't get too worried about. I don't see it like a circle. It should be a circle. Okay, so maybe your resolution is not the correct one to see a circle, but still for Ansa it's a circle. But from this, it's really important right now to remember this millimeters part. And when we explain what are cons and hot points, we are going to enter here and talk about the matching distances and this perimeter length and all these parameters. But right now, keep in mind about the millimeters, okay? So then we have some additional tools which are quite useful. For example, here these orange buttons, you can do all the transform part, so you can copy a part, you can move it, and by copying it means that you can mirror it, you can do asymmetry, you can translate it, you can rotate it, you can do all these operations in that part here. You also have a tool to measure the distance between nodes or between faces, the length of a perimeter, whatever. These are quite important tools in the end. They are quite useful to have it, and they are good to check what we do, and they are also nice to save us some work. It's when I say check, it's because Ansa it's quite a complex program, as most of preprocessors. So if we have some function activated that we don't know that is activated, or we are not aware, basically the mesh is not going to have the size that we want. So it's important that after meshing we just double check at a couple of points that we have the correct length. Then here you're going to have some of your best friends in Ansa, which is a search function. So you don't need to worry about where are the functions themselves. You just need to worry about which function you want to use. Because, for example, let's say now I want to, I don't know, set a different PID for a face. I look here, set PID. Okay, faces, set PID. And Ansa points directly to a set PID, and it activates this function. No, that's quite important, and it helps us a lot to find these functions, as long as we know which function we want to use. So afterwards we enter to the modules menu. There are several modules in Ansa, and in each module we find all the functions that we can that we need to work with them. First of all, we have the topo module that is based on geometry creation and manipulation. Ansa allows you to create geometry, but I don't recommend it for complex geometry like a car or any kind of model. But it's a really good tool, and probably one of the most powerful that you're going to use to clean this geometry, okay? To make it watertight and to be able to generate the mesh properly. So this is possibly the best part of Ansa. And you can find all these functions here in this topo module. Then, as we go to the right, we go to the mesh module. It's the other module where we're going to spend, let's say, the other half of the time of this course. And basically, here we have all these parts for mesh generation. All the functions that we do for surface mesh, for volume mesh, to set mesh lengths, everything. And finally we have the deck. Basically it's just a module where we can choose between our output, okay, our output format, and we can here, let's say, prepare the things for output. No, here we have OpenFOAM output, so we can just set up OpenFOAM files, or also set the refinement size boxes here for our mesh, and so on. And then we have morphing modules. We have some other modules that if we work with them, it's going to be for some specific functions, but just especially keep in mind these two modules, okay? We're going to be changing for this, which is the topo module for geometry, and this, which is the mesh module for mesh creation. Then, if we go to this bottom part of the screen, we have more functions about visibility. Most of them are about visibility and selection. Basically, here we can enable and disable visibility. So possibly this is going to be better explained with some example. But just that part here, those functions here, are referring to faces. So that's how we color our faces. We can color our faces just by entity with the same color, or by PID, so in every PID we're going to have a different color, or part, or whatever, but in our case it's going to be entity or PID. We're not going to go to any other complex structure. So basically, if we have this end, we're going to have the same color for all faces. If we have PID, we're going to have a different color for each PID. And here we can activate or deactivate the shadows of the face like we could do in any other CAD program, no? Then here we have in this bottom right corner modules, we find the auxiliary geometry visualization. So Ansa has two kinds of geometry, the auxiliary one and let's say the one referred to a proper mesh. So the auxiliary one, it's geometry that it's not linked to any meshing in the end, that it's not going to affect to our final meshing, and we just build it. So for example, if we want to build the axis of revolution of or of extrusion of one cylinder or whatever, so we build it with auxiliary geometry, and afterwards we can hide it. That's the auxiliary geometry part. And then we have the same operation but for actual geometry, actual geometry that belongs to our final model and our mesh. And then these buttons here, or these functions, are what are called the Boolean operators. All these Boolean operators are just for visualization. Basically, they just help us to hide some part of the model, or to show it, or just if we want to invert, what we are now seeing, we want to hide it, and what was hidden, we want to see it. Basically, that's something that we're going to play with, and in the end, you're going to see that working with Ansa is about knowing the function that you want to use, but especially working efficiently with these visualization and selection tools. So you're going to have lots of faces, lots of lines in front of your face, and you will need to be able to choose how to visualize it correctly to afterwards take the proper action that you need to do. But if you are not able to visualize it as you should, then you are not going to be able to decide properly, and then there are also some selection tools that it's important that when I explain you in further videos, use this selection tool, for example, loop selection or PID selection. This is because Ansa helps us to be more efficient when selecting parts of our geometry of our mesh. So basically, we don't need to be clicking at all the edges that we want to select. Maybe Ansa can select the 30 that we need to select just by understanding what we want to do. So basically, these tools here have this kind of prediction in selection that are important to use to be efficient and to be fast in Ansa. And finally, this window here is the information window where we see more or less all our process. Here we have a summary of all our processes. Not only that, we also have, for example, if we go here and we go to, set PID, here we see that we have this set PID function selected, and some instructions for the operation. If you want to exit here, we just press escape. That's all for this introduction to the Ansa layout. Then we're going to keep with some visualization. Then this that we're going to learn while working on the square cylinder, and also there we're going to see which entities are part from Ansa, like what are hot points, what are cons, how do we orient faces, and all these things. So that's just the beginning.